In this video, we're going to talk about rational expressions, including multiplying and dividing. So when we're talking about multiplying, dividing rational expressions, we should first go back and think about fractions, since a rational expression is just a fraction and all the operations behave in the same way. When we multiply fractions, we multiply the numerators and then the denominators, but we can simplify beforehand. So I've simplified the numerators and the denominators here by writing the prime factorizations for each one. So then I could go ahead and cancel out any common factors in a numerator and denominator. So I've canceled out a pair of 3s and a pair of 2s, then multiply the factors that are left to get 20 over 11. When we're dividing fractions, since we can't always divide straight across, we change to multiplication, but take the reciprocal of the divisor. So 18 over 21 divided by 12 over 7 turns into 18 over 21 times 7 over 12. But once again, we can simplify beforehand. I'm using the prime factorization method here, and then I can cancel out common factors. So I'm canceling out a pair of 3s, another pair of 3s, a pair of 2s, and a pair of 7s, and then my quotient becomes 1/2. So we're going to use these same principles when we are multiplying, dividing with rational expressions. We're going to factor all the numerators and denominators completely and then cancel out common factors. Once we do that, then we can write the expression as a single expression with one fraction bar. So we're going to take a look at these two multiplication examples first. So for the first numerator, we have a trinomial. This trinomial is a little bit different because we have the order different than we're used to, but we have that negative x squared. So we're looking for two numbers that multiply to -8, but multiply to +8, but add to -7. And those are 8 and 1. But we're not making the 8 or the 1 negative, we're actually making one of the x's negative. So that when we do the inside and the outside, we would have a -8x and a +1x. That would give us the -7. The denominator is linear and there's no GCF, so it is not factorable. That's x plus 8. I just put it in parentheses to remind myself. Same thing with the x plus 5. And this denominator, we have a GCF of 9. Now I have a common factor, x plus 8 and 8 plus x are the same. Here I have 1 minus x and x minus 1, which are almost the same, but since they are subtraction and the order is different, when I cancel them I get a factor of -1. So I'm going to write that negative out in front of my fraction, and that gives me negative x plus 5 over 9, or I could put that negative in the numerator and use parentheses around the x plus 5 over 9, and if I wanted to, I could distribute that negative. In the second example, we have lots of GCF factoring to do. The first numerator, I have a GCF of 10x, which leaves me with x minus 2. In the denominator, I have a GCF of 40x squared. Remember to take the smaller exponent when you're doing GCF. That leaves me with x minus 2. The next numerator, I have a GCF of 16x squared, and that leaves me with x plus 5. And then in the denominator, I have a GCF of 6, which leaves me with x plus 5. Canceling out my common factors, I have two binomial common factors, and then I can start to cancel out monomial factors. So see, I have a common factor x squared here, and x squared here. Cancel those out. And the 10 and the 40 I can cancel out, divide by 10, I get 1 over 4. If this starts to get messy, which it is for me, so I'm going to write out what I have so far. I have an x and I have a 16 in the numerator, 16x, and the denominator I have a 4 times 6, which is 24. Now 16 and 24 have a common factor of 8, so I just divided top and bottom here by 8. All right, let's go on to division. When we are dividing, we're going to take the reciprocal of the divisor and then change to multiplication. So let's take a look at these two examples, which are rewritten here. So again, I'm going to rewrite each of these as a multiplication problem. Some people like to kind of factor as they're flipping and turning to multiplication. You could maybe do that as you get good, but right now I'm just rewriting it as terms of a multiplication, and then I will go ahead and factor. The numerator has a GCF of 2b. That leaves me with b minus 6. The denominator is not factorable, b plus 5. And neither is the other denominator, b minus 6. So I can cancel out the common factors that I have, b minus 6 and b plus 5, and that leaves me with 2b. There's nothing in the denominator except for 1, so I don't have to write that denominator. In the second example, I'm going to go ahead and change to multiplication. Remember, it's only the second fraction that you flip. Once I rewrite this in terms of multiplication, I will go ahead and factor. If the numerator or denominator is a monomial, I don't have any factoring to do, so I'll leave that 5p squared. But in the next numerator, I have a GCF of 5p squared, which leaves me with p minus 7. And in the denominator, also have a GCF of 9, and that leaves me with p minus 4. As I do have a common factor of 5 and of p squared, but it looks like that is it. So let me write this as one expression, which means I'm multiplying 1 times p minus 7, which is just p minus 7. And the denominator is 9 times p minus 4. And you can distribute that 9 if you want, but you could just leave it in factored form as well. All right, that concludes the video on multiplication and division. Hope you enjoyed it.